Hello everyone, we are going to go a little further into modulus function. Here we are talking of transformation for modulus function. One of the transformations we discussed already, but I'm going to repeat it anyway. Transformation means that basically what is modulus function? Modulus function is y is equal to x. Y is equal to x. Modulus x. But suppose the function becomes like y is equal to x minus 2, y is equal to x plus 5, or y is equal to x plus 5, or y is equal to x minus 7, or y is equal to 2x, or y is equal to 1 by 3x. All these functions are different. In this first two functions, you will notice the subtraction or addition to the x is done inside the modulus. This is inside the modulus. Here it is outside the modulus. It is outside the modulus. It will actually be y minus 5 is equal to modulus x, or it will be equal to y plus 7 is equal to modulus x, or here it is being multiplied by a positive number. So I'm going to repeat the first two again. We had already discussed in the previous video, but I'll go quickly with this. That number one, if y is equal to suppose x plus 2, x plus 2, again the same thing. Calculate the critical point. X plus 2 is equal to 0. That implies x is equal to minus 2. Simply draw a curve at x is equal to minus 2. X is equal to minus 2. Now what has happened is that when we are adding, the graph is shifting to the left. Now x plus 2, if you open this, it will be what? X plus 2 will be greater than equal to 0. That will imply x will be greater than equal to minus 2. And it will be equal to x plus 2 minus will be less than 0. Or what will it become? It will be equal to x plus 2. It will be equal to x plus 2 minus x plus 2. It will be equal to the same. It will be equal to the same. It will be equal to plus x plus 2. Just a moment. We have to do it again. It will be plus x plus 2. Y will be, if x plus 2 is greater than equal to 0, that means x is greater than equal to minus 2. It will be equal to minus x plus 2 if x plus 2 is less than 0 or x is less than minus 2. So what we are going to do is we are going to draw the axes, x-axis. This is 0, this is 1, this is 2, this is minus 1 and minus 2. Now the critical point was minus 2 to at x is equal to minus 2. At x is equal to minus 2, draw a V-shaped graph. This graph is for y is equal to x plus 2. This graph is for y is equal to x plus 2 modulus. Now if you notice that if you go beyond minus 2 to the right, if you go beyond minus 2 to the right, then what will you get? This curve you will get. This is y is equal to x plus 2. And this curve is, this line is y is equal to minus x plus 2. So if x plus 2 is to be plotted, it is transformation. It is transformation, is transferred. The original graph, what is the original graph? Y is equal to X will be shifted, will be shifted when we are adding, will be shifted to the left by 2 units, logically also you can see what we have calculated, 2 units as done above. Now, and the equations I have written already for both the straight line. One is y is equal to x plus 2, one is y is equal to minus x plus 2. So now suppose the next is y is equal to x minus 5. So it will be equal to x minus 5 if x minus 5 is greater than equal to 0 or x is greater than equal to 5, and it will be minus x minus 5 if x minus 5 is less than 0 or x is less than 5. Here the critical point is what? X is equal to 5. The critical point is x is equal to 5. So what we can do is we can take 0, x dash x, we can plot 1, 2, 3, 4, 5 and 6. Now the critical point is 5. At 5 what I'll do is I'll draw the graph. At L 5 I just draw a V-shaped graph. At 5 I draw, this is not correct, draw a straight line. What am I doing? Okay, so this curve, this straight line is y is equal to x minus 5 and this line is y is equal to minus x minus 5. So this graph from here, you see this is the original graph. This graph is y is equal to x. It has shifted to y is equal to this position. This is the transformation of the graph. This is the transformation of the graph. In this case, if we have y is equal to x minus 5, then the original graph is y is equal to modulus x. Original graph shifts to right hand side with 5 units, to 5 units. You see, when you're subtracting, generally the idea comes it should shift to the left. It's just the opposite. When you're adding 5, you're shifting it to the left. When you're subtracting 5, you're shifting it to the right. You're doing just the opposite. Like in normal circumstances, common sense would have said that shift it to that side. No, you have to shift it to just the opposite direction. If it is added, shift to the negative side. If it is subtracted, shift it to the positive side. It's a way of remembering it. Suppose now the curve is y is equal to x plus 5. Now notice that 5 is not added, 5 is not inside the modulus. It is outside the modulus. 5 is not added to the x inside the modulus. It is outside. So it could be y minus 5 is equal to x. Now in this what will happen is, now we will shift it downward. We'll shift it, it is minus, we'll shift it upward. We'll shift it upward. We'll shift it upward. We'll shift it upward on the positive side. Like we did here, if it is minus, if you are subtracting from y, then we shift it to on the upwards by 5 unit. Like now let us go upward. 1, 2, 3, 4, 5. If I have to draw y is equal to modulus x, that will pass through the 0. Y minus 5 means I am going to shift it to the positive side. This curve will be like this. This will be y is equal to x plus 5. Now y is equal to x plus 5. Y is equal to x plus 5. So any curve in which you add, you see it this way, that it is shifted to the left, so with y it comes, x remains the same. So if from y we are subtracting, we are shifting it upward. If we are adding something to y, we will shift it downward. We will shift it downward. Suppose I draw a curve here. This curve will be y is equal to x plus 1. Y is equal to x plus 1, because when you will shift 1 to the side, it will become y minus 1. So when we are adding, when we are subtracting k from fx, or in the bracket you can write y, or y, then we shift the curve upwards by k unit along x-axis, along y-axis. When we have shifted, we are shifting it up. When we are subtracting k from fx or y, let us remove this also. This will make it otherwise look like a fractional part of the function. I don't want to create confusion for you. Or y, one and the same thing. Fx or y is one and the same thing. Now let us see. Y is equal to x plus k. Then y will become, y minus k will become x. When we are subtracting something we have already done subtraction, we have done. Now we must do when we are doing this. Now we are adding. When we are adding k unit to y or fx, we shift the curve downward by k units along y-axis y-axis along y-axis. Suppose I want to plot y is equal to modulus x minus 3 1 2 3 minus 1 minus 2 minus 3. So what we'll do is that we will y plus 3 will become x. Now it is addition. We are adding something to y, so it will come down minus 3. This curve is y is equal to x minus 3, or we can say y minus plus 3 is equal to x. When something is added or subtracted to y, the shifting takes place along y-axis. When something is added or subtracted to the x in the modulus, then shifting takes place along the x-axis. Now the fifth one, if y is equal to x and we want to do the transformation y is equal to kx. Now if k is greater than 0, there are two possibilities. If k is greater than 0 or k is less than 1. Suppose it is between 0 and 1. Suppose y is equal to 2x or y is equal to 3x or y is equal to 4x. This kind of curve where we are multiplying the modulus function by some particular number 2, 3 or 4. We are multiplying it by a particular function 2, 3 or 4. So we are multiplying k is greater than 0. 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 Then we are doing this. Now suppose in this what will happen is this is the curve. This is y is equal to, it should appear to be the same. Whatever angle it is making to this side, it should make the same angle to this side as well. Generally, if y is equal to x, 45-degree angle is there. This is y is equal to x, modulus x. Now, if I multiply y is equal to 2x, what will happen? The graph will be compressed towards y-axis. It will be compressed towards y-axis. Suppose I want to draw y is equal to 2x. This will be y is equal to 2 modulus x. Suppose I y is equal to 3x. Suppose I multiply it by further. The bigger the number we multiply, the bigger the compression will be. It will be more compressed. Y is equal to 4x and similarly here y is equal to 4x. When we multiply the factor this modulus x by a number greater than 0, greater zero, like 2, 3, 4, 5, it will be compressed. It will be compressed. It will be compressed. It will be compressed towards y-axis as shown above. As shown above. Greater than 0 is, I mean, it's not a fraction. It is not a fraction. If a number is between 0 and suppose 1, 0 and 1, 1 upon 2, 1 upon 3, 1 upon 4, something like that. Suppose we multiply by, this is fifth. Now let us see the next. Y is equal to x, and we multiply it as y is equal to 1 upon 2x, or y is equal to 1 by 3x, or y is equal to minus 1 upon 5 plus 1 upon 5x, or so on. Then what will happen is, instead of compression there will be expansion. It will be expanded. It will be expanded. Like the smaller the number, the greater will be the expansion. Expansion will be greater. Suppose this is x dash, y dash. Now let me draw first the curve y is equal to x. Y is equal to modulus x. Now if I want to draw y is equal to half x, y is equal to half x, then it will be expanded. It will go away from the y-axis. It will go away from the y-axis. Expansion will be there. This is y is equal to half modulus. Suppose I do it 1 by 3. If I do 1 by 3, it will be expanded further. Y is equal to 1 by 3 x. Y is equal to 1 by 3 modulus x. So that is how the expansion takes place. So these are some of the important transformations of the modulus, and that shall finish our work, because on we have done almost the requirement for class 11th. Thank you.